Before we discuss about the derivative of function, we first talk about the concept of the tangent line, and then later on, we will connect the relationship between the tangent line and the derivative of a function. So first, let us consider a function f defined on some interval let us say in some open interval containing the number x sub 1. So our problem is to find the slope of the tangent line to the curve of f at the point x sub 1 f of x sub 1. So let us illustrate. Say this is the graph of y equal to f of x, and we consider an open interval containing the number x sub 1. So here's the point. X sub 1 f of x sub 1. And let us call it as point P. So we throw the tangent line through P. So TL is our tangent line. And we want to find its slope. Okay. Let us choose another point within the interval and call it as point Q with coordinates x, f of x. So it's any point other than P within the interval. The line PQ, we connect P and Q. So let us choose another color there. The line PQ is now called a secant line. Okay. Let PQ or let M of TL be the slope of the tangent line and M of PQ be the slope of the secant line PQ. Let us consider this triangle. This side is represented by delta y, which is actually equal to f of x minus f of x sub 1, or we can just write this as the difference between y and y sub 1. The coordinates of point P can also be represented by x1, y1, while that of Q can be represented by xy. So delta y is an increment of y. An increment is a small change. So delta y, increment of y. And the other one is delta x. It is an increment of x. So delta x is small change in x, delta y is a small change in y. Alright, so the slope of the secant line PQ is the tangent of the inclination, which is the ratio of the rise to the run. Rise over run, that is the slope. The tangent of the inclination of the secant line. So that will be delta y all over delta x, which is the same as y minus y1 over x minus x sub 1, or f of x minus f of x sub 1 all over delta x. What we do next is we allow Q to move along the curve of F. So let Q move along the curve of F towards point P. Let us see what will happen. So let us choose another point in the curve of F. Let us choose this as another point. Let us call it as Q prime. So PQ prime is another secant line. Okay, so PQ prime is our new secant line. And what do we see here? Our secant line PQ or PQ prime is closer now to our tangent line. So the slope of line PQ approximates the slope of the tangent line. The same thing, the slope of PQ prime approximates the slope of the tangent line. So the slope of the secant line PQ approximates the slope of the tangent line. And the slope of PQ prime likewise approximates the slope of the tangent line also. But PQ prime, the slope PQ prime is a better approximation of the slope of the tangent line. Alright? So if we continue on allowing Q prime to approach P, the slope of the secant line gets closer and closer to the slope of the tangent line. So we say that as Q approaches P, the slope of the secant line PQ approaches the slope of the tangent line as a limit. So we shall write the slope of the tangent line as the limit of the slope of the secant line as Q approaches P. As Q approaches P, our delta x approaches 0. So we can also write the slope of the tangent line as the limit of the slope of the secant line as delta x approaches 0. And we know that the slope of the secant line PQ is equal to delta y over delta x as delta x approaches 0, which is equivalent to the limit of f of x minus f of x1 all over delta x as delta x approaches 0. Our delta x is nothing but the difference between x and x sub 1, and x is equal to x sub 1 plus delta x. So f of x can be written as f of x1 plus delta x minus f of x1 all over delta x as delta x approaches 0. And that is the definition for the slope of the tangent line, the line tangent to the curve f at the point P x1 f of x1. So it's just the limit of the change in y over the change in x as delta x approaches 0. Equivalent to the limit of f of x sub 1 plus delta x minus f of x1 all over delta x as delta x approaches 0. So, if we know the slope of the tangent line, let me just rewrite it. Limit of f of x sub 1 plus delta x minus f of x1 over delta x as delta x approaches 0, we can determine then the equation of the tangent line. So that is y equal to f of x, that is the point P, x1, y1, when we draw the tangent line. Okay. So to find the equation of this tangent line, we will use the point slope form. We have the standard form, the point slope form. One of the standard forms of the equation of a line is the point slope form, which is y minus y1 equal to m x minus x sub 1. Or equivalently, that is y minus f of x1 minus equal to m x minus x sub 1. At this point, let us also define the normal line. The normal line at the point P, or the line normal to the curve of f at the point P, x1, y1, has a slope. Okay, so the normal line is the line, let me define it first. The normal line is the line perpendicular to the tangent line at the point P x1, y1. So if TL is the tangent line, the normal line is NL. And at that same point, it is a line that is perpendicular to the tangent line. So perpendicular to the tangent line there. So the tangent line and the normal line are perpendicular. What is the relationship between the slope of the normal line and the slope of the tangent line? We know that two lines, L1 and L2, are perpendicular if and only if the slope of L1 is the negative reciprocal of the slope of L2. Or equivalently, the product of their slopes must be equal to -1. Okay? So, if the slope of L1 is 3, that means that the slope of L2, which is perpendicular to L1, is equal to the negative reciprocal. So take the reciprocal and then change the sign. So if the slope of L1 is -2, then the slope of the line perpendicular to it is the negative reciprocal. So the negative of -1/2 or +1/2. Take the reciprocal and then change the sign. Another one, if the slope of L1 is 1/3, okay, then the slope of the line perpendicular to L1 will be the negative of the reciprocal. So that will be -3. And to find the equation of the normal line, we use the same standard form, y minus y1 equal to the slope of the normal line, x minus x sub 1. Okay? So the same standard form. The same standard form. One is for the tangent line and the other is for the normal line. So let us have an example. Find the equation of the line tangent to the parabola y equal to x squared plus 1 at the point P 2, 5. When x is 2, 2 squared plus 1 is 5. So the point 2, 5 is in the graph of the parabola. And we want to find its equation. But before finding the equation, we need to determine first its slope. So let us draw the parabola. The parabola has its vertex at 0, 1, opening upward. Okay? And then at the point x equal to 1 or x equal to 2. At the point x equal to 2 and y equal to 5. So that is the point 2, 5, and we draw the tangent line there. So we want to find its equation. At first, we need to determine its slope. So the slope of the tangent line is the limit of f of x1 plus delta x minus f of x1 all over delta x as delta x approaches 0. So our f of x here is nothing but x squared plus 1. Our x sub 1 is the coordinate, x coordinate of the point, so that is equal to 2. So we just replace all x1 by 2. So the limit of f of x1, which is 2, plus delta x minus f of x1, f of 2 all over delta x as delta x approaches 0. Limit of. What is f of 2 plus delta x? So we'll simply replace all the x's in f of x by 2 plus delta x. So replace all the x's by 2 plus delta x. It will now become 2 plus delta x squared. Alright? Our f of x is x squared plus 1, and we will replace x by 2 plus delta x. So 2 plus delta x squared plus 1 minus f of 2. So we shall replace all x's in f of x by 2. That will be 2 squared plus 1. Replacing x by 2, f of 2 is 2 squared plus 1 divided by delta x as delta x approaches 0. So limit of 2 plus delta x quantity squared in the expanded form is 4 plus 4 delta x plus delta x squared. Expanding 2 plus delta x quantity squared. The square of 2 is 4, twice the product, so 2 times delta x is 4 delta x plus delta x squared plus 1 minus 2 squared plus 1 is 5. So minus 5 all over delta x as delta x approaches 0. So we continue here. The slope of the tangent line is the limit of. So we can simplify this. 4 plus 1 is 5 minus 5. Alright? 4 plus 1 is 5 minus 5. Then, for delta x plus delta x squared, we can factor delta x. That is the greatest monomial factor for 4 delta x plus delta x squared. So factoring delta x, we'll be getting delta x times 4 plus delta x all over delta x as delta x approaches 0. So what do we see here? We can cancel delta x. And then we evaluate the limit of 4 plus delta x as delta x approaches 0. By substitution method, delta x becomes 0. So the limit of 4 plus delta x as delta x approaches 0 is just 4. So that is the slope of the tangent line. But that is not yet our final answer because we have to determine the equation of the tangent line. So for the equation of the tangent line, we use the point slope form. So y minus y1 equal to the slope of the tangent line x minus x1. What is my y1? My y1 is 5. The point 25 is your x1, y1. So y1 is 5. Equal to the slope 4 times x minus x sub 1, which is 2. So that is y minus 5 equal to 4x minus 8. Let us write this in the general form. It is a linear equation. So 4x minus y, negative 8 and positive 5 is negative 3 equal to 0. So that is our final answer representing the equation of the tangent line. Okay, so let us indicate it here. So the equation is 4x minus y minus 3 equal to 0. Let us have another one. Find the slope of the tangent line to the curve y equal to 1 over x at x1 equal to 2. Okay? So our f of x is 1 over x and our x of 1 is 2. So your y1 will be equal to 1 over 2 or 1 over 2, that is your y1. So the point here is actually at 2, 1/2. Let us sketch the graph of f. The graph of f is something like this. Okay, asymptotic to both the x and the y-axis. Point 2, 1/2. Where is that? When x is 2, y is 1/2. So the tangent line is somewhere here. There. That is our tangent line. The point is at 2, 1/2. Okay? So the slope of the tangent line is equal to the limit of f of x1 plus delta x minus f of x1 all over delta x as delta x approaches 0. So our x1 is 2. F of 2 plus delta x minus f of 2 all over delta x as delta x approaches 0. So our f of x is 1 over x. We will replace x by 2 plus delta x. So it becomes 1 over 2 plus delta x minus f of 2. So 1 over 2 over delta x as delta x approaches 0. Let us combine the fractions in the numerator. So the least common denominator will be 2 plus delta x times 2. Okay? So 2 plus delta x times 2 times 1, that will be 2 minus 2 plus delta x times 2 divided by 2 is 2 plus delta x all over delta x as delta x approaches 0. So you combine the two fractions. No? The least common denominator is the product, 2 plus delta x times 2. And then you just cross multiply. So 2 minus the quantity 2 plus delta x. So the slope of the tangent line is the limit of, now these two denominators will combine, these two. So writing all of this in the denominator will be getting 2 delta x, 2 plus delta x, right? And then the numerator is 2 minus 2 minus delta x as delta x approaches 0. So 2 minus 2 is 0. What remains there is negative delta x over 2 delta x 2 plus delta x. and delta x will again cancel. So what remains in the numerator is negative 1 over 2 times 2 plus delta x. And delta x approaches 0. Evaluating the limit by substitution method, delta x is 0. So your answer here is negative 1 over 2 times 2 plus 0, or 4. So that is the slope of the tangent line, negative 1/4. Whenever the slope is negative, that means that the line is leaning to the left. And indeed, our tangent line to the curve of f at the point 2, 1/2 is leaning to the left. The slope is negative 1/4. Let us have another one. Find the equation of the line normal to the graph of y equal to x squared minus 2x at x equal to 1. Okay? Y equal to x squared minus 2x at x equal to 1. So that is actually our x sub 1. So when x is 1, y is negative 1. So 0 and 2. Oops. 0 and 2. Okay. When x is 1, negative 1. So the graph is actually a parabola opening upward. The point P with coordinates 1. Okay, so our x sub 1, let us calculate now. X sub 1 is 1. So our f of x is x squared minus 2x. So f of 1 is 1 squared minus 2 times 1 is negative 1. So the point is 1, negative 1. The point is 1, comma, negative 1. Then, let us draw the tangent line. There's the tangent line. Okay. So the slope of the tangent line is the limit of f of x1 plus delta x minus f of x1 all over delta x as delta x approaches 0. Limit of f of our x of 1 is 1. So 1 plus delta x minus f of 1 all over delta x as delta x approaches 0. Our f of x is x squared minus 2x. So replace all x's by 1 plus delta x. So 1 plus delta x squared minus 2 times 1 plus delta x. Again, our f of x is x squared minus 2x. Replace all x's by 1 plus delta x. So 1 plus delta x squared minus 2 times 1 plus delta x minus f of 1. So we replace x by 1. 1 squared minus 2 times 1 all over delta x as delta x approaches 0. So, expanding 1 plus delta x squared, that will be 1 plus 2 delta x plus delta x squared minus 2 minus 2 delta x minus 1 squared minus 2 is negative 1. So negative of negative 1 is positive 1 all over delta x as delta x approaches 0. So let me change this. That is delta x squared. Alright. So what do we see here? 1 minus 2 is negative 1 plus 1 is 0. So for the remaining terms in the numerator, what do we have? Oh, 2 delta x cancels with negative 2 delta x. So what remains in the numerator is delta x squared all over delta x as delta x approaches 0. But delta x squared over delta x is just delta x as delta x approaches 0. And if we take the limit of delta x as delta x equal to 0, that is 0. So it's obvious that the slope of the tangent line is 0 because the tangent line is horizontal. The tangent line is a horizontal line, and if whenever a line is horizontal, the slope is 0. So, the slope of the normal line is the negative reciprocal of the slope of the tangent line. So what we will be getting here is negative 1 over 0, and that is undefined. Okay? Undefined. A vertical line has no slope. No? If it is undefined, that means that the normal line, this means that the normal line is vertical or is a vertical line. So, what we do is we construct a line perpendicular to the tangent line at the point P 1, negative 1. There. So, that is our normal line. And what is the equation? For vertical line, the equation is x equal to a constant. So since it passes through the point 1, negative 1, the equation of the normal line is x equal to 1. There. It passes through the point P1, negative 1. And the equation of a vertical line is x equal to a constant, and that constant is the x-coordinate of the point. The normal line has no slope. Why? Because the normal line is a vertical line. So, you do some exercises. 1. Okay, so find the equation of the tangent line to the given curve at the specified points. So the first one is y equal to, say, 4x minus x squared at x of 1 equal to 1. Then 2, y equal to 2 over x minus 2 at x1 equal to 1 also. Then 3, y equal to the square root of x at x equal to 4.